Hey again, Steve here, answering an area of a parallelogram problem. Here's the parallelogram, and given we have two sides, one of length 8, one of length 6. We also know that these diagonals intersect, and one of the angles is given, 114. Based on complementary angles, we know that the other angle here is 66. I've labeled a point here, or a line segment from this point of the parallelogram to the midpoint of where they bisect. I label that A, and then notice by similarity with the red that this is also A. And then I've labeled the other diagonal from here to the midpoint B, and then correspondingly here. What we're going to use in this is, here I have a reference triangle. Notice that I have A and B match with a big angle C in the opposite side C. So we're going to use this and the law of cosines, as well as the side angle side formula to find the area of a triangle as shown here. Again, all reference to this triangle. So our first step in solving this problem is to first look at this triangle right here. And notice I'm going to have, substituting this into the law of cosines, my C term is 8, so 8 squared equals B and A. I don't know the length of these, so I'm going to leave them as variables. And then I do know this angle here as the big C. Similarly, I'm going to do the same for this triangle right here. So here is my C, which is 6, and here's my interior, or my angle 66. So this looks like it may be where are we going with this, but what I'm going to do, now I have these two equations, I'm going to subtract them. So now I have 8 squared minus 6 squared. Notice what happens when I subtract these. The b squared plus a squared terms cancel out. And when I subtract this, this essentially becomes positive. Notice the 2ab is common, and now I'm left with cosine of 66 minus cosine of 144. However, because of the complementary angles, these two angles have the same magnitude but different signs. So what happens is, first of all, on the left side, 64 minus 36 becomes 28. And what happens is, when I recognize that cosine formula, it'll basically be twice of cosine of 66. You can prove that to yourself on your calculator, but these two expressions on the right are now equal. So instead of 2ab, it's now going to be 4ab, because this other cosine, when combined with this cosine, basically has a doubling effect. Okay, but you can prove that to yourself. So now what I'm going to do is just solve for the combined term AB by dividing cos, and this is what we have here. So 28 divided by 4 is 7, and then bringing the cosine. So we have this as our first step. Now the next step is I'm going to use the side angle side formula right here, where the angle, I could basically pick either one because the sine of 66 equals the sine of 114. So I'm just going to pick this, substitute that angle, try to solve for my area, but look, I have my AB right here, so I'm going to substitute that in. Now I have a sine over cosine. What's sine over cosine of the same thing? That's tangent. So I have 7/2 times the tangent of 66. What this gives me is the area, okay? And notice that these were given in inches. So inch times inch would be inch squared. So when I go 7/2 of tangent of 66, I get 7.861 square inches. However, this is not your answer. This is the answer of one of these triangles, either this triangle or this triangle. They are equivalent. And so basically what we need to do is multiply that by 4 to get the total of all 4 triangles, or hence the total area of the parallelogram. Okay, so see if this makes sense. And again, please review the law of cosines in the side angle side formula. There's other ways you can solve this real quick. Another way you could do this is take these two equations. You know how we just subtracted them? You could subtract them and then add them and actually solve for AB, and then come back and use the side angle side formula directly. So that'd be a great check if you want to do that as well. Thanks for watching.